Okay, this is the next video in the quadratic series. We're going to solve quadratic equations by factoring. You learned some of the basics of factoring when you were in Algebra 1. Take a second and look at the cartoon. I hope you can read it. It's kind of small. One way to think of factoring is to multiply binomials. I wanted to give you two methods of doing this. Many times people will multiply across, and it's really just the distributive property, right? So you would take the x and you would multiply it times the first and the second term. So that would be x squared plus 3x. Then you would take this next term and do the same thing. It's just that. So it's plus 2x plus 6. These are common factors or like terms. So we would add those together and on you go. I said two methods. That's the method that you're used to. I don't like the word FOIL because no one ever does FOIL exactly the way it says, first, outer, inner, last. It's basically just the distributive property, and you already know how to do that. Another way to do that, though, is sometimes they call this the box, but this is just being able to multiply sideways. So you would take x times x and get x squared, x times 2 and get 2x, x times 3, 3x, and then 3 times 2 is 6. These are always like terms, and you get the same thing. There's actually one other way that you can do it, and that's just using regular multiplication times, right? So this is 6, this times this is 3x, down here 2x and x squared, and you get the same thing. So whatever method you use to multiply, I'm going to have to re-say that. That's going to be three methods. There is a way that you can do that. In fact, you can always work backwards as well. So I'm going to talk about a few methods of factoring. One is factoring out a greatest common factor, a GCF, greatest common factor. So I look at these two terms here and I see that they don't both have an x, but they both are factorable by 4. So I factor out a 4 and I get x squared minus 5. And that doesn't factor any further. It is the difference, but not the difference of two squares, because 5 is not a perfect square. So this would be done. You just factor it out. If I had 2x squared plus 6x, then I could factor out not only a 2, but I could also factor out an x from both of those, and I would have x plus 3. And then I would double check, use the distributive property, make sure I can get back to it. But factoring out a GCF. Then sometimes you can have other patterns, like one of the patterns is a perfect square. So you see here that this is x squared, this is also a perfect square. And since it has a middle term, you can actually factor it. These first two here, x times x is x squared. The factors of 5 or 25 are 5 and 5. Since this is a plus here, those are plus, so this would actually be x plus 5 quantity squared. An interesting thing about multiplying out a perfect square is that if you go back, like if I go ahead and multiply this out, you'll notice that this term right here is just x squared, and this term over here is 25. This is a plus. This is always plus. To get this term right here, you would just multiply 5 times x and double it, and you've got it. So there's a pattern that you can do here. To factor this, once again, this is going to be z plus 6 quantity squared. Once again, you would have z squared, right? 36. The middle term is 6 times z doubled, 12z, and that's plus, and that's always plus. Now, if this is a minus, then this becomes minus, and so does this, all the way down. It's a great idea to try to recognize the perfect squares. It makes factoring so much easier. The difference of two squares, usually what you see is, if it's factored, this is really simple, minus 2, x plus 2. One of the factors is positive, the other is negative. I put some stinkingly hard ones on here, and I'm not exactly sure why. But if you can see here, 12 is not a perfect square, right? Neither is 27. So, but the factors, and I don't know what happened to my thing here, but this should be a 2. That's an 8, that's a 2. So one thing I can do is factor out a greatest common factor. 3 is a factor of both of these. So I would have 4b to the 8th minus 9c squared. Now I've got perfect squares. So this would be, just leave the 3 out here. This would be 2b to the 4th, 2b to the 4th, minus, plus, 3c and 3c, and there you go. And that's done. You can do the same thing here. You'll notice that these are not perfect squares, but if I factor out a 2 from both of those, it would be. So I factor out a 2, and that's going to be 9d to the 6th minus 25f squared, right? So then I'm going to write it down here, plus and minus, difference of squares. So I've got 3d to the 3rd, 3d to the 3rd, and then 5f, and then 5f. So these are the difference of two squares with factoring out a GCF first. Right? So if you don't know what the perfect squares are, all that means is 1 squared is 1, 2 squared is 4, 3 squared, you know, all the way down to 10. 10 squared is 100. So if you can recognize those, these are easier to find. Okay, so here are factoring trinomials of the form ax squared plus bx plus c, where a is equal to 1. Okay, and usually the x squared term has a positive coefficient. It's easier to factor that way, and I don't know what happened to my 2, but it's there. So what we're doing, generally, most people see this as a puzzle. We remember from multiplying it out that x times x is x squared. Okay? And then we know that this is positive. So that means that this last term came about from multiplying these two factors. So what are there's the factors of 15 are 1 and 15 and 3 and 5. And only 3 and 5 add up to 8. So these are going to both be negative. And then how do we guess? Well, we do x times x is x squared minus 5x minus 3x plus 15, and we get the same thing. All right, so if we factor this one, we know this is x, and then the factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. And which one is the only one that has a difference of 2? That's 4 and 6. All right, so now we have to figure out the sign, and since this one is negative, that means that these two have to be opposite signs. So since this one's positive, that means the bigger number is going to be positive and the smaller number will be negative. And we have this. So let's double check it. X times x is x squared plus 6x minus 4x minus 24, and that equals what we started with. I always check it. I think you should too. Okay, now this one gets a little trickier when you're trying to factor trinomials of the form where a is not equal to 1. All right, so the first thing that I want to do is I want to double check that there's not a greatest common factor that I could factor out. But because that's a 9, 2 is not a factor of 9, so I'm going to have to do something else. Now I'm going to show you a method that I use, and it takes a little bit of getting used to, but it's the only thing I use for these anymore because it eliminates a lot of guess and check. All right, so what I do is I make an x, and I recall that this 2 is a, the negative 9 is b, and c is negative 18. So here I'm going to write what it looks like. I'm going to ignore this one for right now, the other one. But up here I'm going to do a times c and write it in. Down here I'm going to do b. So if you look at a times c, that's going to be negative 36, and I include the sign. B is just the negative 9, the middle number. All right, what I need are two factors of 36 that either add or subtract to get b. Okay, they add or subtract to get b. So I've got 1 and 36. I'm going to ignore the negatives for now. 2 and 18, 3 and 12, and then I'm looking there. 12 minus 3 is 9. So that's what I want. 3 and 12. All right. Now, 3 plus 12 is 15. So not negative 9. So this is going to have to be a negative 12. 3 plus a negative 12 is a negative 9. I'm almost done. I'm going to divide both of them by 2 and reduce if possible. 3 halves doesn't reduce, but negative 12 over 2 is negative 6. Okay, those are my factors. So to factor this, I'm going to write this one. 3 halves is going to turn into 2x plus 3, and the other is going to be x minus 6. Well, let's see if we're right. So I have 2x squared minus 12x plus 3x minus 18, and it's the same answer. All right, so let's try this one. Let's do the same thing. I've got negative 12 because I have a times c in the top, and negative 11 here. Well, there's not that many, there's, I guess, a few factors of 12. So 1 and 12, notice that that makes 11. So 1 and 12, make that a minus. Only this time I'm not dividing by 2, I'm going to divide by a, that's 3, and reduce if I can. So this one is going to be 3x plus 1, x minus 4. I did that really fast, because once you learn how to do this, it is so much easier than guess and check. My suggestion would be to learn this. Now I only do this where a is not equal to 1. If it's equal to 1, I use guess and check. But when it's not, I almost always do it this way. The zero product property just means that once you factor it, you can set each factor equal to 0 and solve. So solving x squared minus x equals 2 by factoring, the first thing you want to do is set it equal to 0. So that's going to be x squared minus x minus 2 equals 0. A equals 1. So I'm just going to factor with a guess and check, because this is x, this is x. The only factors of 2 are 2 and 1. And then I figure this out. They've got to be opposite signs, because this is negative. And then because the middle term is negative, then the bigger number will be. And I have this equals 0. Now I'm going to check it. And I have x times x is x squared minus 2x plus x minus 2, and that it gets me originally, so I'm good. So I'm going to set each of my factors using the zero product property. X equals negative 1. And I set x minus 2 equal to 0, so x is equal to 2. So my solutions, my x-intercepts, my solutions, my zeros, are negative 1. Don't write it like that. Hold on. X equals negative 1 and 2. And those are my answers. Okay, I would like for you to do these two problems in your notebook. This is an z squared equals 16z. Solve them both by factoring, and we will check these when you come to class. Take a little bit of time, write these down. See you in class.